Hello, my distance learning chemists. We're going to start out chapter 16, uh, notes, math stuff, whatever you want to call these little lectures that I give you guys. Um, Lesson 16 is about acids and bases. And so, um, to know what acids mean basically goes back to, I believe it's Greek or Latin. Um, and the word acidus means sour. And so what we find is many acids have a sour taste, maybe even a sour smell. Um, if you have ever peeled an orange and you had a little hangnail or something like that, you might notice that your cut or your hangnail really burns, it stings. Well, that's what acids tend to do. When they get in a cut, they sting or they burn. Acids have what we call a pH of less than 7. um, P has to deal with a term that is associated with what we call the log function on your calculator. We'll talk about that in a couple lessons down the road here. But just knowing, if you look up here, pH, it's a small p and then a capital H. But the H stands for hydrogen ion. And so hydrogen ions are what make something acidic. And basically, another factor with acids is that they turn something called litmus pink. Litmus is something we call an indicator. Indicators are special compounds that scientists have discovered over hundreds of years of studying these things turn a different color at a specific pH. And so litmus just happens to set the line right at 7. If you're below a 7, you're an acid and you turn litmus pink. If you're above a 7, you're a base and you turn litmus kind of a bluish slash purple color. But anyway, bases are substances that tend to taste bitter. If you've ever tasted soap, that real bittery type taste is a result of that it is a base. One kind of interesting sidelight is that one of the reasons we think humans developed the ability to taste bitter is that a lot of things that are poisonous in nature have these things called alkaloids in them. And alkaloids are either psychotropic, meaning that it makes you high as a kite, or they can be very damaging to you and even kill you. And so being able to taste bitter was valuable in the human evolution, in that people who learned to taste this bitter went, "Oh, I'm not going to eat that because I know every time I've eaten something bitter, I've gotten really sick." Um, I saw my grandpa eat that and he died. So, that, going back to Darwinism and the strongest survive, that ability to taste bitter would have been helpful in our evolution. Again, we talked about bases. NaOH slowly dissolve your skin. It's why it feels gooey or slippery. But basically, pH is greater than 7 and again turns litmus blue. But one thing that the book talks about is this little experiment that I was going to do for you guys where you boil a purple cabbage, red cabbage, they call it. And basically, you get this purpley colored solution. And then, if you read about it in the book, if you put an acid in it, it turns it kind of a pinkish color. If it is neutral, if it's around just pure water, basically you end up with it staying purple, and then it goes to kind of a greenish color if it has a couple of drops of base put into it. So again, red cabbage just happens to be something that is a natural indicator. The substance that's in the cabbage is a natural indicator. So anyway, the last thing I wanted to talk about here is the pH scale. And so the pH scale is up here on the board behind me. But basically, it starts at 7 here in the middle, and that is your pure water. Now, one common misnomer about the pH scale is it only goes from 0 to 14. Well, 0 to 14 is our most common substances, but there are some very powerful acids, some very powerful bases, very strong, that will go below 0 or above 14. So I think the highest known base will actually get you to something like I believe it's a 17, and then you can get to around a -2 or 3 for pHs, but very rare substances. So this is something that you're not going to run into a common basis, but battery acid, for instance, is below 0, might even be around 1, but sorry, -1. Then 0, again, most commonly your lowest uh, acid pH. Stomach acid's about a 1. Lemon juice is about a 2, 2.5. Tomato juice is around a 4. So hopefully you see that citric, kind of soury taste. That is your acid. Okay, then we look at rain. Rain actually comes in at about a 6.7. It's a little bit less than 7. And this is because as rain falls, it picks up carbon dioxide and turns into something called carbonic acid. This carbonic acid is just a very mild acid, but this is not what we would call acid rain. This is our typical rain. Acid rain is when we dissolve other substances into the rain, and that can be potentially down around a 4 or 5. And that's where you start, causing some big problems with when it rains, this real acidy rain, it destroys trees and things like that. So anyway, once we get to a 7, a neutral is just pure water, we go to seawater. Seawater's typically somewhere in the mid 7s to an 8. It just has some dissolved minerals in it that have basic properties, and it's just over the hundreds of centuries of the earth dissolving stuff here on land. It has made the ocean just slightly basic. Then we get to something called washing soda, maybe around a 9. Ammonia is around a 10 or 11. And then you get to your drain cleaner, your Drano, plumber's helper, all those kind of things. That's about a 13 or a 14. Very good at dissolving hair. That is why we put that drain cleaner in. So anyway, I hope that helps with assignment 84, the homework on 84. If you have any questions, again, tyrick@auhsd.net. Have a good one, and we'll get 85, 86, 87, 88, 89 out shortly.